All right, cool. So this is factoring by grouping. Again, this is another lesson. This is when it starts to get a little weird, when we start to have to do more than just remember a pattern. This is a much more complicated pattern, at least. It's going to feel a bit like we're doing some really acrobatic type stuff here. This is factoring by grouping, and basically this means that we've got 4 terms. Okay, anytime you've got 4 terms, 1, 2, 3, 4, right? Anytime you've got 4, we're going to be doing grouping. Okay, it's pretty much our only strategy for dealing with 4 terms. The way it works in Algebra 2 is probably 70% of the time we're going to be working with 3 terms. Probably 25% of the time we're working with 2 terms, and very rarely we've got 4 terms. And so if you've got 4 terms, these are kind of like rare questions, but you have to do grouping. And the reason we're learning this now is because, as you see here, we're basically just using GCF twice. Now, as much as GCF was easy, and this is also not too bad, this is very strange. So let's look at this example here. What's going on is we're basically going to put a little divider in here and split it into these 2 terms and these 2 terms. And once we split it up, we're going to do a GCF of this left and then a GCF of the right. So when we do a GCF of the left, we can take out a y, and we're left over with a y minus 3. Over here, we can take out a z, and we're left over with a y minus 3. Now, the most important thing when it comes to grouping is that these 2 things have to be exactly the same, okay? You have to have y minus 3 on the left. Okay, it has to be y minus 3 on the right. If this works, what you're going to do is basically y minus 3 is going to be one of your answers, and your other answer is going to be the leftover stuff, y and plus z. And so that's how you're going to come up with your 2 solutions here. Again, it's weird. You're going to do a GCF and a GCF. You better have the same things, and then that will make one answer. The leftovers will make the other answer. Really what's going on is that we are identifying that we can do a big GCF and take out the y minus 3 and the y minus 3, but a lot of times that just confuses students to think about it like that, so I don't really work on it too much. Now over here, this question is another example. It's already done for us. We're going to put a little divider in. The reason I want to talk about this one is that when they've done this, they've got 2x minus y. Over here, they've got minus y plus 2x. Now, this is a rare issue. You don't see this very often, but if you do, you got to know what to do. Is 2x minus y the same thing as minus y plus 2x? Yes, these are the same. Okay, so this is like if you had 3 minus 1 and you had minus 1 plus 3. Are these the same thing? Yeah. So these are exactly the same signs. A positive 2x, a positive 2x, a negative y, a negative y. They're just in different orders. And so these are actually still the same thing, right? So this is 2x minus y. Both of these things here are 2x minus y. And then the leftover stuff is where you get your other answer. 2x plus 7x, 2x plus 7, or that's a z, sorry. 2x plus 7z, and there we go. Okay, let's do one of these questions. The sooner we do them, the easier they'll be, I promise. Okay, we're going to do number 1. We're going to want to split this up, so I really recommend you draw this line. But a real strategy is be careful, okay? A lot of times I see students, they draw this line and they go right through the plus. And that's not very good, because now you don't know if this used to be a plus, if this used to be a minus, and that's important for us to remember. So don't draw it right through the plus. Draw it between the plus and the other term. So now I've got 2 over here, 2 over here. What do these have in common? Somebody help me out. 6 and 3. What can we do, GCF? 3. What about letters? X is coming out? What about Y's? Yeah, I agree with you. Left over with 2x squared plus. Now, what about this? We got 3y and we took out 3y. This is where we have to leave behind that 1, okay? This is something we talked about with GCF on Monday. A little tricky. You got to remember that 1. You got to keep the 1 as a little placeholder to make sure it works. So the big idea is this better be over here, right? We better find that 2x plus 1 over here, right? Once we do this, sorry, it's 2x squared. We need this to exist over here. Otherwise, the whole thing is ruined. So what can we take out from an 8 and a 4? A 4. And then what's left over? 2x squared plus 1, right? Exactly what we need. And now we are very happy. So we are allowed to now finish our question here. We take the stuff that's the same. That's one of the answers. We take the leftover stuff. That's the other answer. 3y plus 4. How's that feel? Does that feel okay? Again, it's weird. It's like jumping through hoops a little bit, but it's really just GCFs. Take your time and make sure that these match. Now, I'm going to jump all the way to number 6. Because number 6 is really the only time we might run into something that's a little bit harder. And it looks like it would be a pretty easy question. We split it, but don't split it on the minus, right? Be careful. Split it in front of the minus because this minus is very important. We want to keep track of this. What do these have in common? A squared. We can do a GCF. Take out an a squared. Left over with 2a minus. We had an a squared. We lost the a squared. We got to keep the 1 there. Don't forget about the 1. Don't forget. And now when we go over to the other side, we need to have 2a minus 1. When we go over here, I'm thinking that we have a 5 in common. And left over, negative 2a plus 1. Now, this is a problem, okay? We have the wrong signs on our leftover stuff, okay? We are not happy because these are not the same. Now, before, if we go back up, sorry, I got to zoom in, it takes me a second. If we go back up here, we decided that this was the same, right? But that's because that's a positive 2x, negative y, negative y. So it's all the same parts. They're just backwards. Down here, though, we've got different parts. We've got plus 2a, minus 2a, minus 1, plus 1. So these are actually different. So we need a strategy to fix this issue. Okay, and this strategy is a little tricky. Okay, I have had plenty of students who kind of struggle with this a little bit. Anybody have an idea what we can do to fix this problem? Anybody have any ideas? It's definitely a little sneaky. What we're going to do is instead of taking out a 5, we've got all of our signs backwards. So what we're going to do is we're going to take out a negative 5, okay? Because if we take the negative away from the 10a, it will become a positive 10a, and then we take the 5 away, it'll become a positive 2, and that's what we need. So we can take out negatives with GCF as well, and we have to do that for this question. So when we take out that negative 5, I don't know why it does that sometimes. When we take out this negative 5, we lost the negative, we lost the 5, so we've got 2a. And then this is a little weird too. We've lost the 5, so it's going to be a 1. But we took out a negative from a positive, and it's actually going to leave it behind as a negative. There's two ways to think about this. If you distribute this, you're going to see negative 10a plus 5. So that's good. That's a good way to check it. Another way to think of it is that if this is a plus 5, it's kind of like a minus 5, because two minuses make a plus. And so if we're going to lose the 5 and lose one of the minuses, we're still going to have another minus left. And that's why it's going to be a minus 1. It is a little weird, but we got to use this strategy. We use the strategy, we fix it, and now we are feeling good again. A squared minus 5. So that is solving by grouping. If you have 4 things, split it, GCF, GCF, make sure they match, finish the question. That's it. Hope this was helpful, and see you next time, I guess.